Hey guys, sorry for the long delay on this video. So I should have had this expansion updated posted a long time ago. But spring is here, I got distracted with some other stuff, but here it is, ready at last. For anybody that hasn't already watched my large solar generator how-to series, this video is a follow-up to those. In those videos I show you step-by-step how to build the main unit, as well as have links to all the components I used on the blog post for the series. A lot of the feedback was asking how to expand the solar generator to an even bigger capacity system. When I designed the base unit, I wanted it to be very easily expandable using quick connects. There are two areas where I designed it to be expanded. First is solar charge capacity, which will increase the rate at which the unit can recharge our batteries. And second was to be able to expand the battery bank, giving your inverter an increased runtime at higher loads, or when solar conditions are poor. As a bonus, the battery bank expansion unit can also be used independently with our quick connect. We are going to cover how to build both of these expansion upgrades in this video. On the solar side of things, we used a 30 amp PWM charge controller when we built the solar generator. We also connected it to a 100 watt solar panel, which when in full sunlight will provide just over 5 amps to the controller. Most solar panels will have their specs listed on the back of the panel, as you can see here. You can see that the maximum possible current for this panel is listed as the short circuit current. In reality, the panel should never be fully shorted when connected to our charge controller, unless we have a problem with our wiring. But it's still important to keep this number in mind when sizing the wire. The other number, optimum operating current, tells us the max current that we will get out of this panel under perfect conditions. Our charge controller is listed as a 30 amp controller, which means it technically should be able to handle 5 of these 100 watt panels, all connected in parallel. But they don't want you to push it to the full 30 amps, and in the documentation for the controller, they recommend never exceeding 80% of this max current. That brings the total number of these panels we can connect in parallel to 4. It is also possible to connect panels in series as well. I will explain the differences between parallel and series wired panels in a later video, so be sure to subscribe if you're interested in that. We can add up to 4 100 watt panels in parallel very easily using the MC4 connectors on the back of the panel, with the addition of 2 4-to-1 MC4 adapter cables. We will hook the single end of the 4-to-1 adapter to our cable that leads to the solar generator. We want to tie the plus wire leading to our solar generator to the plus wires coming from each panel. It does not matter which of the 4 connectors goes to each panel, as long as the polarity matches. We then use the other 4-to-1 adapter cable to connect the negative wires in the same way. You will be able to connect either 1, 2, 3, or 4 panels using these adapter cables. The polarities of the wires on all 4 panels should match, so that you cannot hook them up backwards, but it's always a good idea to check the polarity label on each wire as you hook them up, just in case a mistake was made at the factory. The total wattage will increase by 100 watts with each panel as they are added. For the battery bank expansion, I decided to go with a VMAX SLR-125 battery. Some of the feedback was wanting to have a higher amp hour rating than what we were able to get with the Optima Blue Top that we used in the solar generator build. The Optima Blue Top had an amp hour rating of 55 amp hours, whereas this one is actually rated at for 125 amp hours, so it actually has over double the capacity. The high current quick connects on our solar generator will allow us to connect this battery in parallel, giving us a total of 180 amp hours of storage for our inverter. The battery is quite heavy though, weighing in at 75 pounds. It is also considered a Group 31 battery, so it is fairly big. I purchased this battery case, which is compatible with Group 31 batteries, as well as several of the other larger battery sizes. We will be using it as an inexpensive housing for our battery expansion unit. We will be wiring up 2 of our high current quick connectors to this expander unit. By adding 2 of them, it gives us an extra connector so that we can daisy chain additional battery units, or still use any of our other accessories with the solar generator without having to disconnect the battery first, like the jumper cables, the 12 volt winch, etc. Now to connect the quick connects, we're going to use some high quality welding wire. This is actually 4-gauge wire, and it comes with a 10-foot length of red as well as black. The advantage to using the welding wire for this is that it's a very durable insulation, it has a lot of abrasion resistance, and it's also very flexible. We will also need to get some copper lugs that will make our connections from the welding wire to the battery. I also purchased an additional triple gauge pod with the 12-volt battery gauge, 12-volt automotive socket, and USB power output. This is optional, but it allows us to check the battery voltage when it's not connected to the solar generator, as well as it makes the battery unit much more useful by itself. The first thing we're going to want to do is put the battery into our case. For the main wiring, the first thing we're going to want to do is strip enough wire off the negative wire so that we can attach one of the lugs for our quick connect. You can either use a large set of cable crimpers like these here, or if you do not have them, as they can be quite expensive, you can also partially crush the crimp onto the wire using a bench vise. Just tighten it down fairly tight. Don't squish it to the point that you're pushing the wire back out of the crimp, however. Well, then once you have it partially crushed, follow up by taking a punch and driving 2 large divots into the face of the flat area. This will help to ensure that the wire doesn't pull out inadvertently. It's always a good idea to give a good tug on your connections just to make sure they won't pull out. Tape the connections. This is to help ensure that any loose wires don't come out of the connector and possibly cause a short later on down the road, as well as gives us a little bit of additional strain relief. Looking at your quick connect, you'll see that there's a plus and a minus mark. Make sure that you take the red wire and it goes into the side labeled with the plus. You'll see that there is a flat, sharp corner on one side of the connector. That one should slide in so that it clicks in place with the little spring tab that's inside your connector. You should have a very positive click sound when it's correct, and you should not be able to pull it back out. Then do the same with the black wire. Next thing we need to do is just install the weatherproof cap for this connector. Decide how much extra wire you want to have sticking out from your battery expansion unit. You want to make sure that it is long enough that you can position it anywhere you want it beside the solar generator and still reach your high current connector. Once you know this number, go ahead and mark this on the wires. Then place that mark on the edge of your case, and while holding that there, then mark both the negative and the positive wire next to their respective terminals on the battery. Cut your wire at both of those marks, and then crimp in and connect a battery terminal. Use the same process that we did for attaching the lugs on the high current connectors. Now you should have 2 battery terminals connected, offset so that it fits nicely and will fit off the side of the battery case. We're going to repeat this exact same process for the other connector, except that we want this one to stick out the other side of the battery unit. This time we'll have a longer negative cable and a shorter positive cable. Once you have both sets made, you can go ahead and connect them to the battery. Remove the bolt from the battery and connect both of the positives. We want to add a bolt, a spring washer, a flat washer, our cable connections, another flat washer, and then thread that into the top of the battery. Just hand tighten it at first, and then position the terminals approximately where you want them to actually end up, and then slightly tighten with the ratchet. Do not over tighten with the ratchet. It is possible to rip these connections out of a battery. You want them to be just nice and snug. You shouldn't be able to move them around by hand, but you don't want to torque on them too hard either. Then go ahead and repeat the exact same process for the negatives. When you get done, it should look like this. Now we can go ahead and snap on the lid to our battery unit. Make sure that it clicks securely on both sides. The battery case also comes with a strap. It helps to make sure that the battery lid doesn't come off by accident, and it actually can also double as a carry handle. These battery units are quite heavy, but it is possible to carry them by the strap. Feed the strap around the battery case. Go first through the loops, then up and around the top loop and back down through between them. There's a snap fit edge to these, and once you have everything positioned and tightened where you want it, they will click together and it should lock securely. You should be able to pick up the entire unit with the strap and not have it slip. I've also found that the strap is a pretty handy way of storing the high current connectors on the side of the case. And this is the complete unit. It can be ready to be used with our solar generator. If you do want to install the optional 3-gauge pod, I will go over that very quickly, because we use the same components in the main solar generator as well, and the installation is very similar. If you would like more detailed instructions, refer to the component mounting and the generator wiring how-to videos. If you would like more detailed instructions, refer to the component mounting and the generator wiring how-to videos. We will need to drill 3 1 1/8 inch holes. We will mark and drill the center hole first, and then use the gauge pod faceplate as a guide to drill the other 2. Once those are finished, we will need to mark where we want the power switch for the gauge pod, and then drill a 13/16 hole. Then we are going to daisy chain the black ground wire, just like we did for the main unit. We want to connect our ground wire to all 3 gauge pod units, and then as well to the power switch. When connecting the daisy chain ground wires to the power switch, we will want to connect it to the brass connector. That is the ground connection for these switches. And we also want our daisy chain to continue on with a long extra length of wire that we will later use to connect to the battery itself, and crimp on another ring terminal so that we can later connect that to the battery. Now we're going to do the exact same process with the power wire. We're going to daisy chain it to all 3 components on our 3-gauge pod. And then we're going to run that daisy chain over to our switch. In this case, it will only need to connect to the center switch connector. We do not need an extra length of wire to go to the battery, because this is the load wire coming off the switch. Now we will want to add an inline fuse that goes from our battery to the power connector on our switch. So go ahead and snip the middle wire of the fuse and crimp another one of the ring terminals to the shortest side of the wire you just snipped in half. Then hold this up against our battery along with the negative wire and determine how much additional length you will need. Then we're going to splice in an additional length of wire to be able to reach the power connector on our switch, which is going to be the opposite side connector from our ground wire. Once that is complete, go ahead and add the ring terminal for our 3-gauge pods into the stack, just like we did with the 2 positive wires coming off of our quick connectors. Matching all the positive connections onto the positive terminal of the battery, and all the black negative connections to the black terminal. Snug them down, and once that's complete, we can go ahead and reassemble the lid to our battery case. It may be a good idea to test it first, just to make sure. When you flip the switch, the blue light should come on, you should see some battery voltage, and you should also have a blue light on the USB output connectors. And that's it. This is our completed battery unit, now with the optional gauge pod installed as well.
We can add in as many of these battery units as we want. These are being tied in parallel, so they're not increasing the voltage to the unit at all. They're adding to the amp hour capacity. So to do that, we have a second high current port that's also tied into this box. So we can basically just daisy chain as many of these boxes as we would ever need. There's really no limit to how many of these batteries you can tie in, as long as they're all being wired in parallel as they are. And all that's going to do is just increasing the runtime and the amp hour capacity that the inverter can pull from. Now because there is a limit in the number of solar panels we can hook up with our current charge controller, we have a 30 amp charge controller which allows us to do the 4 panels. There is a limit in terms of how many batteries that those panels could realistically recharge. But that's all going to depend on how much load you're using and how your conditions are, how sunny it is, how cloudy it is, how much sunlight your panels are receiving. So really those are things you'd kind of have to work out for yourself. But on the battery side of things, you can add as many of these as you want. You could conceivably add 6, 8. It would give you an extremely long runtime. Eventually you'd run into an issue where your panels just may not be able to keep them all fully charged. I demonstrated this before, running some portable tools off the inverter, but with the added capacity in the 2 panels, it really makes for a really nice experience. It's kind of interesting to be out here in a field. Typically, if you're used to working off generators, you've got that constant noise of the engine running, the chattering, making sure it's topped off with gas. It really is nice to be able to work with the peace and the quiet. I hear the birds chirping. I don't have any of that noise. Not until I go ahead and fire up my saw. And it's as simple as that. There are some even bigger inverter options. This is a 2000 watt inverter that I went with. It does have a 4000 watt peak. It's been able to run most of the tools that I've tried to use. The one exception I ran into is an air compressor. It was a portable, one of the bigger sized portable air compressors, and it wasn't quite able to run that. The compressor would start to spin, but after about 2 cycles of the motor, it would fault and the inverter would shut down from an overcurrent limit. I expect I should be able to run some of the smaller air compressors, but I haven't actually tried that yet. However, on the other side of things, there are even bigger inverter options in this line. There is a 3500 watt unit, which is another 1500 watts beyond what this has, which should, in theory, run just about anything you can plug into a standard 110 outlet. You know, anything that would run off a 20 amp breaker off your house. And I believe there's even a 4000 watt unit. I don't know if the 4000 watt unit would fit into this case. And I would actually have to double check with the 3500 watt. I'm pretty sure they would fit in the case. We might have to move some things around a little bit, shuffle them a little bit. Those are things I may be looking into if there's an interest in that. Let me know in the comments if that's something you guys would like me to explore and see what the options are for that. But I've been really happy with this. It's been able to do everything I've needed it to do. And now with the ability to add extra capacity and with the panels, I probably won't need more than 2 panels for anything I do. Honestly, the 1 panel has been pretty sufficient, but I do know that there's a lot of situations where people are using things more throughout the day than I am. Typically when I've been using this, it's for very short durations. Anytime that I'd be pulling out a gas generator and I don't want to run a mile-long extension cord from the house, this has been able to come in really handy for that. It'll also be really handy for camping, jump charging, jump starting vehicles. It's quite easy to move around with the roller case. The case rolls very nicely with the handle, almost kind of like airport luggage. A little bit heavier, but it rolls pretty good on those wheels, even in this grass. It's pretty manageable. If you decide to add the USB and 12 volt gauge pod, not only do we have a gauge to tell us how full our expansion battery is, but we can also then use it for running 12 volt air compressors. Say we're trying to fill up some tires on a vehicle, don't have power over by the vehicle, and we don't want to have the full generator set up. This battery has more than enough capacity to run a 12 volt air compressor or many other 12 volt accessories with no problem at all. And since we also have the USB port, that actually allows us to charge things like our cell phone. This is a 15,000 amp hour USB battery pack. It's actually one of the larger sizes as far as USB battery packs go. And 15,000 milliamp hours comes out to about 15 amp hours. This is 125 amp hours. So the marketing for this claims that you can charge a typical smartphone anywhere from 4 to 5 times, depending on the model smartphone. Now, of course, amp hour ratings are pretty much just a rough estimate, but that means, in theory, if you believe the marketing material on that, we should be able to recharge the phone on this at least 30 to 40 times without having to recharge this battery. So in theory, if you were to have this out in the field somewhere, even without the solar panels, you should have almost a month worth or more of charging capabilities for your smartphone. I also discovered that my friend's 12,000 pound winch that he bought from Harbor Freight uses the exact same connectors as these. So if we have his winch out on the trailer, and we don't have a vehicle nearby to run the winch, I can pull this battery pack out there and we can plug our Harbor Freight winch directly into this, and we have a 12,000 pound winch with a fairly good runtime. Which, one more thing that makes me really glad that I used these connectors the way I did, I'm finding that they can come in useful for a lot more things and beyond just the quick connect for our solar generator.
And that's it. Check out the video description for a link to all the components, as well as to my blog. Let me know in the comment section if there's anything else you'd like to see or any questions you have with this video. And please don't forget to like, share, and subscribe. Thank you.